You step into a barn on the peak of a sweltering August day. Outside, the thermometer shows 96 degrees. The cattle are breathing heavily. The chickens have ceased laying. The loft radiates heat like an oven. Yet, the moment you cross the threshold, the air strikes you as refreshingly steady, cool, not cold, holding firm at 55 degrees. This is the same temperature as it was in January, and it will remain unchanged next August. No fans whir, no motors hum, no electricity bill piles up. The difference between this barn and the one you know? A simple 6-foot deep trench and a length of pipe, $300 total, less than a single diesel tank. This is a technique the Amish have quietly perfected since the 1840s, while utility companies charge thousands annually for less effective systems. I discovered one such barn near Berlin, Ohio. There was no ventilation, no compressor, just a man named Eli smiling, gesturing toward the bare dirt floor. This method works equally well in barns built last year or in structures your grandfather raised in 1962. Before the end of this story, I'll reveal the single insight the Department of Energy made certain local extension offices would never share. Imagine this. 6 feet beneath your feet, the soil maintains a constant temperature. It doesn't fluctuate whether it's January in Pennsylvania or July in Georgia. At this depth, the Earth holds steady between 52 and 58 degrees Fahrenheit, year after year, century after century. Soil temperature studies by the U.S. Geological Survey confirm this, with records dating back to 1965. Every American farmer sits atop a vast, cost-free reservoir of climate control, yet almost none are tapping into it. For nearly 2 centuries, the Amish have known how. When the first Old Order Amish arrived in Lancaster County, Pennsylvania, in the early 1700s, electricity was unavailable. Even if it had been, they would have rejected it. Yet their livestock still required protection from August heat waves and February freezes. Milk needed cooling. Seed grain had to remain dry. Their solution? They relied on what generations in Germany's Palatinate region had long practiced: digging. They excavated a trench 6 feet deep, stretching from outside the barn into its interior, sloped slightly downward. Within the trench, hollow clay tiles, commonly used for field drainage, were installed. The external end opened to a shaded intake, shielded with fine wire mesh to block pests. Inside, the pipe emerged through the barn floor, usually behind a modest wooden cover near the animal stalls. Here's the science. Air from 95-degree summer heat enters the intake. As it moves through the buried pipe, the surrounding cool earth extracts the heat. By the time the air reaches the barn interior, it has dropped nearly 40 degrees, arriving at 55. The warmer, lighter barn air rises through a cupola vent, creating a natural pressure difference. This pressure draws more cool air through the trench. No motor, no fan, only physics and patience. The Amish call this system a cool groin, or cooling trench. Modern engineers later rediscovered it, dubbing it an earth-air heat exchanger. Yet the Amish had been operating them 70 years before the first patent in 1923, and at a fraction of the cost. Even today, the material cost for such a trench runs around $300, including clay tiles, gravel bedding, mesh, and a simple shroud. Labor comes from the community. A barn-raising crew can install one in a single afternoon. Once buried, it lasts a century with zero maintenance. No filters to replace, no coils to clean, no refrigerant to refill, nothing to break. Compare this to modern cooling setups. A commercial dairy in Wisconsin invests roughly $18,000 in fans, ducts, and wiring before switching anything on. The USDA Economic Research Service reported in September 2014 that heat stress costs American dairy farmers an estimated $900 million yearly, assuming their cooling systems are running. The Amish trenches eliminate that entire loss for just $300. In 1923, researcher Lauren Neubauer of the University of Nebraska measured ground temperatures at multiple depths across 42 Midwestern farms. His bulletin, scarcely read at the time, showed that at exactly 6 feet, soil temperatures remained stable between 52 and 56 degrees Fahrenheit, regardless of January or August conditions. He noted that Amish farms in Lancaster County and Mennonite settlements near Gann, Indiana, had employed this 6-foot depth for ventilation trenches since at least the 1840s. He wrote that these communities had discovered the optimal depth through generations of careful observation, without instruments, academic input, or apparent necessity. Neubauer admitted being frankly astonished. The bulletin saw 2 reprints in 1924 and 1927, then vanished. By 1931, Agricultural Extension Services shifted focus entirely to electrical solutions. The Rural Electrification Administration was being built in Washington, and the vision for American farming was electric wires in every barn. Passive systems were deemed outdated, reminiscent of what grandparents did, considered unprogressive. Thus, the knowledge lay dormant, preserved only in the soil and the memories of those who dug trenches each spring. So why has this method been hidden? Why don't local extension offices provide blueprints? Why are American contractors promoting $6,000 HVAC systems when a simple trench accomplishes the same result for life? The answer is both surprising and disheartening. In 1978, the U.S. Department of Energy commissioned a study on passive geothermal cooling in agricultural buildings. Lead researcher Dr. Frank Hovind of Brookhaven National Laboratory traveled through Lancaster and Holmes counties, interviewing Amish farmers, measuring barn temperatures, and documenting trench construction. His final report, filed in 1983 as Technical Document TM8314, concluded that earth-coupled passive ventilation could cut agricultural cooling costs by 94% compared to mechanical refrigeration. It could be added to any existing barn or outbuilding with a basement or accessible foundation. This report was intended for distribution to every county agricultural extension office, but never reached them. By 1985, it was restricted, and by 1989, it vanished from public archives. According to a Freedom of Information Act request filed in 2007 by a homesteading publication, the report was suppressed not because it was flawed, but because it functioned too well. Internal memos cited it as a significant disruption risk to the residential and agricultural HVAC industry. Read that carefully. The suppression occurred because 3 companies, Carrier, Trane, and York, built their entire commercial agricultural divisions on the expectation that American farmers would keep buying mechanical cooling units indefinitely. A $200 trench dug by a man with a shovel didn't align with their business model. During the energy crisis of 1978, an engineer named Fred Reed was brought in by a modest Pennsylvania dairy cooperative to investigate why Amish barns in the area stayed cooler during summer than the modern, mechanically ventilated barns of their neighboring English farmers. Reed dedicated 11 months to this study. He recorded air movement, monitored humidity, and analyzed bacterial levels, essentially measuring everything he could conceive. The conclusion of his final report, a photocopied excerpt of which exists, stated that the Amish ventilation trenches achieved approximately 83% of the efficiency of a commercial $10,000 HVAC system. The estimated cost? $270 for materials and 4 days of labor with a 6-person crew. Reed suggested the cooperative consider adopting the method. The cooperative declined, not due to any failure of the technique, but, and here I quote from Reed's report, the lack of an ongoing service contract, replaceable filters, and manufacturer warranty rendered the system commercially unfeasible from a maintenance revenue perspective. Pause and digest that. The system was rejected because it performed too effectively, too cheaply, and required no replaceable parts that could generate profit. This pattern repeats itself again and again. Yet the Amish never stopped digging. Their work continued unbroken. Every barn erected in Lancaster County from 1850 onward includes some version of this trench. Dairy parlors across Holmes County implement variations of the system. Preservation of this knowledge wasn't due to advocacy, but because the Amish ignored the pamphlets that county extension offices had ceased sending. They simply persisted in what their forefathers had practiced. When I met Eli on his porch in Berlin, Ohio, in the summer of 2019, I asked if he had ever encountered the Hooven report. He laughed. His grandfather had installed the trench under his current barn in 1934, having learned the method from his own father, who had immigrated from Switzerland in 1872. Eli emphasized that the only manual needed was the soil itself. The system is straightforward. The pipe sits 6 feet deep, matching the frost line of much of the eastern United States and the depth at which soil temperatures stabilize year-round. For a typical 1,000 square foot barn, the pipe is 8 inches in diameter, scaling up to 12 inches for larger structures. The total horizontal length must be at least 100 feet. Allowing air ample time to exchange heat with the ground. The slope should be a 1/4 inch per foot downward toward the barn, so condensation drains inside without pooling. Yet the Amish didn't stop at the trench. They added a refinement that improves both function and hygiene. At the base of the pipe's internal exit, where cool air enters, a shallow layer of crushed limestone is installed, usually 4 inches deep and 2 feet wide. This bed absorbs condensation before it soaks the floor and chemically interacts with ammonia from animal waste, neutralizing odors common in ordinary barns. With a properly installed cooling trench and limestone bed, the barn remains not only cool but fresh-smelling, and the interior carries the scent of hay, even in August. For those who already own older barns or homes built before 1980, this isn't only for new construction. The Amish have a method to retrofit these trenches without permits, contractors, or disrupting existing foundations. This adaptation is called the side entry trench. Instead of running under the building, the pipe runs alongside, ending at a basement window, crawl space vent, or dirt floor stall door. First, mark a trench line of at least 100 feet, ideally on the north or east side for minimal sun exposure. The trench must remain 6 feet deep throughout, but a 24-inch width suffices. A single individual using a rented mini excavator can complete it in about 6 hours, with rental cost around $200 for the day. The pipe is laid with the correct slope, backfilled with a foot of gravel for drainage, and then covered with the original soil. At the building end, cut an 8-inch opening through the wall at floor level or a basement window, sealing the pipe with hydraulic cement. The external intake receives a small wooden hood, painted dark green to blend with the environment, and a 1/4-inch hardware cloth to exclude rodents and snakes. That completes the retrofit. No permits, no contractor, no inspector, no electricity connection required. Maintenance is minimal, a garden hose flush every 5 years to clear sediment. Even a 70-year-old with a bad back can operate a mini excavator for 6 hours. The Amish call this the elderly trench because it's used to retrofit older structures, often small cottages attached to the main farmhouse. These are the spaces where grandparents, who feel summer heat the most, reside. The trench restores the comfort of their youth without any electrical bill. For structures on a slab, the perimeter trench offers a slight variation. The cooled air enters through a low vent in an exterior wall instead of the floor. The principle is identical, and costs remain about $300 in an afternoon of work. None of this appears on YouTube, in home improvement stores, or homesteading magazines because the residential cooling industry benefits from systems that require maintenance, service calls, and refrigerant refills. A trench like this, requiring virtually no upkeep, is the worst-case scenario for HVAC companies. They actively ensure you remain unaware of it. Yet, there's one more secret the Amish have kept, something Eli revealed at the very end of our conversation. Delivered with his customary calm, as Amish men do with important matters, it almost sounded like casual talk. Before sharing that final insight, one note. Everything uncovered from Brookhaven archives and Amish barns, the 6-foot trench, the limestone bed, the side entry retrofit for barns built in 1962, the buried clay pipe, fits into a broader system I've documented. Over years, I've traced airlines, curing processes, heat management walls, and other techniques from Lancaster and Holmes counties. I organize these methods room by room, season by season, reflecting how families actually use them. This collection is called the Amish Home System. According to Bishop Christian Stoltz's diary entry on August 14, 1847, this method transforms a barn at 55 degrees into a 48-degree cold storage room, keeping milk fresh for an entire week without consuming a single watt of electricity. He wrote that the trench alone already provides excellent results. The combination of trench and limestone bed already improves barn cooling, but there exists a third component, almost entirely absent from modern references, that transforms a barn at 55 degrees into a 48-degree cold storage room. This temperature keeps milk fresh for a full week. It preserves meat. It protects seed potatoes throughout winter without a basement. The Amish have practiced this since 1847. This third element is a buried clay water jar. Placed at the midpoint of the trench's 100-foot run, the Amish install a single unglazed earthenware jar, generally 2 gallons in size, within a small side chamber dug into the trench. The jar is filled with rainwater and sealed with a wooden stopper. Over time, the unglazed clay slowly releases water through its walls, evaporating into the moving air inside the trench. This evaporation cools the incoming air by an additional 7 to 10 degrees, supplementing the cooling effect provided by the earth itself. The result is air entering the barn at 48 degrees, refrigerator-like temperature maintained year-round from a simple clay pot. The earliest documented account of this technique comes from the diary of Amish Bishop Christian Stoltz, dated August 14, 1847, archived at the Lancaster Mennonite Historical Society. Stoltz recorded installing what he referred to as a Wazer Krug beneath the cooling trench of his new barn. He noted that milk from his cows remained sweet for 8 days during the August heat, an outcome unmatched by neighbors relying on traditional surface spring houses. Within a generation, the method had spread across the community, yet it never appeared in any English-language agricultural publications, not in 1847, not in 1947, and certainly not in 2024. Modern science only began to fully explain the principle in the 1960s. Known as evaporative geothermal coupling, it occurs when the stable coolness of deep soil interacts with the latent heat absorbed by evaporating water, producing a combined cooling effect greater than either method alone. The University of Arizona's College of Agriculture published research confirming the principle in 1968, but applied it exclusively to large-scale greenhouse cooling, never connecting it back to the small Amish trenches that had utilized the same method for over a century. To implement it yourself, acquire a single unglazed terracotta jar, usually sold for approximately $18 at garden centers as irrigation pots. Dig a modest side chamber at the midpoint of your trench, just large enough to hold the jar upright. Fill it with rainwater, insert a wooden plug, and bury the chamber. Maintenance is minimal. Once or twice per year, uncover the jar, refill, and replace the plug. That is the entirety of care. The jar can last up to 50 years if kept intact. Cooling begins immediately and continues without interruption. No one Neighbors, power companies, inspectors will notice it exists. Imagine a barn on a mid-July afternoon. The sun beats down on the south-facing wall at 3 o'clock, and outside air registers 94 degrees by the water pump thermometer. Inside, the cattle rest quietly, breathing slowly and evenly. Flies exist, but do not swarm, as gentle, steady airflow moves from the trench inlet across the floor and exits through the cupola at the ridge. Wall thermometers read 55 degrees. Straw remains dry. Wood beams carry faint hints of cedar and old hay. No hum of compressors interrupts the silence. No electricity bill ticks away in the background. Only the ancient, slow breathing of the earth moves through the trench, dug by a grandfather in 1911, maintained by a son, then a grandson, and now a great-grandson who learned to keep roots from intruding by watching his father on Saturday mornings as a 9-year-old. This is what was taken from us. Not the barn, not the land, but the uninterrupted transmission of practical knowledge, handed down from one generation to the next, lived rather than written. When the chain broke, extension services pivoted, bulletins went out of print, engineers like Fred Reed were told their reports were not commercially viable, the knowledge did not vanish. It went underground, into communities that had never trusted the wired grid anyway. It lived on with Amish, Mennonites, and a handful of stubborn Appalachian farmers who saw no reason to fix what was not broken. Today, it is returning, slowly and quietly, one trench at a time, one barn at a time, one descendant at a time, keeping memory alive. I asked Eli one final question that afternoon. Why had his community never patented the technique, never authored a book, never tried to sell it? He looked at me long, and then said something that has stayed with me ever since. When knowledge is given to you for free, he explained, you do not have the right to charge for it. You have the duty to pass it on. And that is precisely what he was doing. That $300 trench, that 18-ton clay jar, a barn that remains at 48 degrees with no electricity, no machinery, no monthly bill. These materials are available at your local hardware store. The soil lies beneath your feet. The only obstacle was the silence of an industry that profits from your dependence. If you recognize that real knowledge has been quietly withheld to protect someone else's profit, you already know your next step. Walk your property this weekend. Examine the perimeter. Locate the north or shaded side where soil stays cool and damp. Measure out 100 feet. What you do with that 100 feet will change every summer for the rest of your life and for those who inherit your land. Consider what your own family once practiced. Was it the 6-foot depth unknown to most? The limestone bed that cleans air while cooling? Or the buried clay jar that drops another 10 degrees using only a few dollars worth of rainwater? Share your memory, your family's old techniques. That is how the knowledge comes back to us. Everything you need has always been under your feet. The dirt, the trench, the wisdom passed silently through generations. It was never lost. Next week, a demonstration will show an Amish method for keeping a root cellar at 38 degrees throughout July, using only a copper pipe, a length of jute rope, and a specific tree planted exactly 14 feet from the cellar door. The original system was installed in 1889 and has operated uninterrupted for 135 years. Until then, examine your barn, inspect your land. Look closely at the soil beneath your boots. Everything required is already there. It always has been, even if no one has bothered to tell you.